Good day. So today I will provide you additional solving problems about lines in space. Let us work on this first example. It says here, the line L with parametric equations x equals 1 plus 2t, y equals 2 minus 3t, z equals 2 plus t passes through the point P1 whose coordinates are 1, 2, 2. To what vector v is it parallel? So to solve this problem, let us graph the given line L and the vector v. So this is now your xyz axis. So then let us assume that we have here point P1 whose coordinates are given. And we have here this line L. So this line L will pass through the given point P1 whose coordinates are 1, 2, 2. And we have the parametric equation of your line L given as x equals 1 plus 2t, y equals 2 minus 3t, then z is equal to 2 plus t. So we can say that line L will really pass through this P1 whose coordinates are 1, 2, 2 because if you're going to check the parametric equation of your line L, we have x sub 0 is 1, y sub 0 is 2, and z sub 0 is 2. So with that, we can now also define now the vector v to whom this vector v is parallel to your line L. And this vector v can be drawn from the initial point. So this is our vector v, and we will define its components. So since it says here that where vector v is parallel to our line L, so we can now say that vector v will have the same components of your vector on your line L, which we have it as 2, negative 3, 1. So therefore, we have it again as 2, negative 3, 1 is the vector v to whom our line L is parallel to. Let us work on this example number 2. It says here, are the lines L1 and L2 parallel? So we have here the parametric equations of your two lines, L1 and L2. So for us to determine if line 1 and line 2 are parallel, if you recall last time that two lines are parallel if they are scalar multiples of one another. So we have the concept last time that vector u equals c times v. So we can say that the vectors u and v are parallel. So let us work on your vector of your line 1 and let us have this as vector u. So the components of your vector u on your line 1, we have it as negative 1, 2, and 1. That is based from the coefficients of the parameter t. Then for your line 2, let us denote this as vector v. So we have the components of your vector v as 2, negative 4, negative 2. So it is obtained again from the coefficients of the parameter t. So we can factor out here common to the numbers, let's have it as -2. Then we're going to divide each component by -2. So 2 over -2 is -1. -4 divided by -2 is +2. Then -2 divided by -2 is 1. So let us check if we have the same components when we multiply -2 to our components of your vector. So we have -2 times -1 is +2, then this is -4, then this is -2. So as you can see, we can say that vector u is equal to c times v, where c here is equal to -2, then we can say that line 1 is parallel to line 2. So that is how we define if two lines are parallel. So using the concept of scalar multiples. There is another concept of defining if two lines are parallel, and that is by defining their cross product. If the cross product of these two vectors becomes 0, then we can also say that line 1 is parallel to line 2. So let us now find the cross product of these two vectors. So we have it as I, j, k. Then we have vector u is -1, 2, 1. Then vector v is 2, -4, -2. Then using basket method to find the determinant of this 3 by 3 matrix, so let's copy the first two columns. So we have I, -1, 2, then j, 2, -4. So let us check if this is equal to 0. So with that, let us now perform the diagonal multiplication starting from the upper left corner. This is -4i. Then we have +2j. Then we have +4k. Then minus, we have this as +4k. Then this is -4i. Then this is +2j. So let us check if it is equal to 0. So let's now combine similar terms. -4i minus -4i will be 0i. Then 2j minus 2j will be 0j. Then 4k minus 4k will be 0k. So that means we have here 0 vector equals 0. So we can say therefore that line 1 is parallel to line 2. Let's work on this third example. It says here, find the parametric equations for the line whose vector equation is xy equals 2, -3 plus t, 1, -4. So we have here a line into space because of the presence of two coordinates, two components of your line L. So with that, let us recall again the parametric equation of your line L. So we have x equals xo plus at, y equals yo plus bt, then z equals zo plus ct. Therefore, your line L will have the parametric equation x equals 2, this will be your xo, then plus, you have it as 1t. Then you have y equals yo, which we have it as -3. Then plus t times -4, we have it as -4t. So we will not include the third parametric equation because, as I've said, this involves line into space. So we have this as the answer parametric equation for the line whose vector equation is given.